the mystery of Oumuamua has been one of the most fascinating and perplexing riddles in the field of astronomy. Ever since its discovery on October 19, 2017, this interstellar object has captured the attention of scientists, researchers, and the public alike. What made this object so intriguing wasn't just the fact that it was the first known interstellar visitor to our solar system, but its strange and baffling characteristics that defied the conventional expectations of what an asteroid, comet, or even a cosmic object should behave like. As Oumuamua passed through our solar system, its unusual acceleration and lack of typical cometary features led to a swirl of theories, some of which even proposed that it might be an alien spacecraft. Could it really be something out of this world? Or is there a more conventional explanation that we simply haven't uncovered yet? Let's go back to the moment when Oumuamua first entered our detection systems. The object was first noticed by astronomer Robert Wyrick using the Pan-STARRS 1 telescope in Hawaii. Initial analysis quickly confirmed that it was traveling at a speed far greater than what would be expected of any object bound to the Sun. It was moving too fast and on too unusual a trajectory to be considered a regular member of our solar system, which immediately led to the conclusion that it must have come from somewhere outside our cosmic neighborhood. For the first time, astronomers were observing something that had made its way to our solar system from another star system, an interstellar visitor. At first glance, Oumuamua seemed like a fairly typical object. It appeared to be an elongated rock, and its reddish hue suggested it had been exposed to cosmic radiation for a long time, giving it the appearance of an asteroid. But as scientists started to gather more data about its speed and trajectory, something peculiar became apparent. After passing near the Sun in September 2017, Oumuamua began to speed up in a way that didn't quite make sense given the gravitational influence of our star alone. Objects passing through our solar system generally behave according to predictable gravitational mechanics. So, why was Oumuamua accelerating in such an unexpected way? At first, the hypothesis that outgassing, something typical for comets, might be responsible for the unexplained acceleration was put forward. Comets are known to release gas and dust as they get heated by the Sun, which in turn pushes the object forward in what is known as the rocket effect. But as astronomers studied Oumuamua further, they found that there was no visible tail or coma, no gas or dust being ejected into space. That was the first big clue that something was amiss. Without outgassing, how could an object gain speed? Over the course of a few weeks, astronomers started to reject the comet hypothesis entirely. But then, in a surprising twist, Oumuamua was categorized as an asteroid. The problem with this new classification was that asteroids typically follow more predictable orbits and don't exhibit the strange behavior that was now being observed. Oumuamua showed no signs of the typical properties of an asteroid, such as rotational patterns or a consistent trajectory. What was happening here? Theories began to evolve, and soon there were whispers that we might be dealing with something much more extraordinary than just a cosmic rock. Among the most intriguing theories proposed was the idea that Oumuamua was not a natural object at all but rather an artificial one. This theory, championed by Harvard professor Avi Loeb, suggested that Oumuamua could be a probe or some kind of spacecraft sent by an advanced extraterrestrial civilization. Loeb argued that the object's unexplained acceleration and the lack of any observable outgassing could be explained if Oumuamua were a type of solar sail, a very thin, flat object propelled by the pressure of starlight. In essence, Oumuamua might be a form of alien technology, designed to use the power of stars to move through space. Loeb's controversial hypothesis sparked a wave of debate and excitement across the scientific community. The idea that Oumuamua could be an alien probe captured the imagination of many, while others were more skeptical. To this day, the idea of an alien origin remains a subject of much debate, and while no evidence has been found to support the theory, it remains a tantalizing possibility for those who are open to the idea that we may not be alone in the universe. However, despite the alien hypothesis being the most sensational, most astronomers have stuck with more conventional explanations. Theories based on natural phenomena have continued to be refined as more data on Oumuamua has become available. For example, one theory suggests that Oumuamua could be a fragment of a larger, broken-up body, possibly the remains of a comet or an asteroid that had been traveling through interstellar space for billions of years before encountering our solar system. This fragment could have been made up of materials that are particularly sensitive to solar radiation, which might explain the speed increase observed as it passed the Sun. Further studies revealed that the object exhibited strange fluctuations in brightness as it moved through space. These variations were too significant to be explained by normal rotation or changes in the way it reflected sunlight. It seemed as though the object was tumbling through space, rather than rotating smoothly as most asteroids do. The peculiar shape of Oumuamua, which was described as being cigar-shaped or elongated, was also a source of fascination. It appeared to be much more elongated than typical asteroids, which tend to be rounder or more irregular in shape. Could this unusual shape be the key to understanding the strange brightness fluctuations and its odd flight characteristics? Some researchers have speculated that the object might be made of a material with highly unusual properties, such as a metallic or composite material. This would explain why it didn't display the typical signs of a comet or asteroid, like outgassing or dust trails. Others have suggested that the object could be composed of hydrogen or nitrogen ice, perhaps ejected from a distant exoplanet, similar to the icy bodies found in the outer reaches of our own solar system, like Pluto or the Kuiper Belt. Yet even with these theories, scientists were left with more questions than answers. Theories based on natural causes were still lacking when it came to fully explaining Oumuamua's behavior, especially its unexpected acceleration. In the midst of this uncertainty, many telescopes and observatories around the world turned their attention to the object. The Green Bank Observatory in West Virginia, for example, pointed its radio telescope at Oumuamua to check for any signals that might suggest an artificial origin. Despite the excitement surrounding the possibility of discovering alien technology, no artificial signals were detected. The object remained as mysterious as ever. So, if it wasn't a comet, and it wasn't an alien spacecraft, what was it? As scientists struggled to make sense of the data, new hypotheses began to emerge, combining both natural and more exotic explanations. One promising theory, proposed by scientists Daryl Seligman and Jennifer Bergner in 2023, suggested that Oumuamua's behavior could be explained by a process involving hydrogen ice. Their theory, grounded in research into the behavior of water ice in deep space, posits that Oumuamua could be composed of frozen hydrogen, a substance that behaves differently under the extreme conditions of interstellar space. The theory goes like this: when a body travels through the cold reaches of interstellar space, it is subject to intense radiation from distant stars. This radiation can break down water ice into atomic hydrogen, which remains trapped within the ice. As the object gets closer to a star, like our Sun, the heat causes the hydrogen gas to escape from the ice, creating a form of outgassing that doesn't produce visible tails or coma, because the hydrogen is transparent to spectroscopic instruments. In this way, the hydrogen could accelerate the object without leaving behind a visible trail, and because the object is so small and compact, the acceleration could have a noticeable effect on its trajectory. In addition to this, the peculiar rotational behavior of Oumuamua, the fact that it seemed to be tumbling rather than rotating smoothly, could also be explained by the properties of the hydrogen gas escaping from the object. As the gas builds up pressure and escapes in a non-uniform way, it could cause the object to spin erratically. This would also explain why the object's brightness fluctuated in such a dramatic manner. The hydrogen escape would not only affect its speed but its shape and orientation as well, creating a chaotic tumbling effect as it moved through space. While this theory isn't the final word on the subject, it provides a compelling explanation for many of the strange characteristics of Oumuamua. By combining elements of traditional comet science with new insights into the behavior of hydrogen in deep space, Seligman and Bergner have offered a plausible scenario that doesn't require invoking extraterrestrial technology. It's a theory that may not have all the answers, but it's one that fits the data we have and provides a new lens through which we can understand the mysterious interstellar visitor. Despite these advances, Oumuamua still holds some of its mysteries close. The object's true origin is still unknown, and its behavior continues to be a subject of intense research. Whether it is a fragment of an ancient interstellar body, a chunk of frozen hydrogen, or something entirely unexpected, one thing is certain: Oumuamua has already altered the way we think about space and our place in the cosmos. It has forced us to reconsider what we know about the objects that populate our universe and open our minds to the possibility that we might not be the only intelligent life in the galaxy. As we continue to investigate Oumuamua and the many other interstellar objects that may pass through our solar system in the future, we can expect new insights and discoveries that could reshape our understanding of space and the potential for life beyond Earth. The story of Oumuamua is far from over, and perhaps one day, the final piece of the puzzle will fall into place, revealing the true nature of this extraordinary visitor from the stars. Until then, we can only marvel at the mystery and excitement that continues to surround Oumuamua and the possibilities it represents for the future of space exploration. So, what do you think? Is Oumuamua a natural object, a product of interstellar forces we don't fully understand, or could it be something far more extraordinary, a piece of alien technology sent from another world? Let me know in the comments below.